Hi all, welcome to what is part one of a 6-part video podcast where I'm going to look at all the technology that's involved with chassis and geometry, and we're going to go right the way through from prototype chassis to production based chassis. And before we get on to the geometry parts, which we said we'll cover in some of the other episodes, which is going to be our adjustable yokes, our swing arm pivots, our linear linkages, our rake angle adjusters, I want to start right at the beginning, because as I said in the introduction video that I did, I really want you to go through this step by step. It's the only way you're going to get a full understanding. So if at any point I'm teaching my grandma to suck eggs, I apologise. However, the idea is I want to cover all skill levels that are involved here so that everybody gets a full understanding, so bear with me. So as I mentioned right at the beginning, I want to kick off with chassis. Now, I felt the easiest way to try and explain all of this to you was to literally have a Moto Evo bike that I'm currently building in front of you for you to be able to see the devil and the detail of it. And below, what you see down here in the front is one of my GP2 prototype chassis. And we're going to talk about the issues with a production based chassis in comparison with something like a prototype chassis. Now, the reason chassis are so important is flex. It's the key thing that allows tyres to wear evenly, for your tyres to stay in contact with Mother Earth at any given time. So let's begin by looking at our production chassis. Now, when a manufacturer builds a chassis, it's a road bike. Now, we all know I specialise in Triumphs, and so the latest rendition from Triumph is the ST765. It is a sports tourer. Be understanding of that, it is not a race bike. Now, when you go back to the old Daytona 675 and also the 765 Moto 2 LE, they're very, very different bikes. One, in my view, was designed for track work. That's the 765 LE Moto 2. The ST765 is a sports tourer and designed for humping you and a friend and luggage all the way across Europe. So think about that for a moment. When the manufacturer builds the bike, it's built for a specific purpose. You are trying to redesign it in some way to work in a different way, and that requires a lot of thought, a lot of process, but that's what we're going to be going through in these videos. So when I build a Moto Evo, I don't use the 765 chassis. It's not my favoured tool. Why? Well, rake angles and also the way that the linear linkage is attached to the main chassis. I see those two areas as a bit of a problem. The third area is our swing arm here. On the ST765, it's around 30 millimeters longer than what it is on the 675. Now, if you want to understand that in its simplest form, why did Triumph make the Moto 2 edition bike in what is essentially a 675 chassis? Because it was designed for some track work, and therefore that was the best chassis to use. Now, first of all, let's have a look at the headstock, and then let's compare it with the prototype chassis underneath us. There is a vast difference. You've got fairly minimalist spars going to the front of the prototype chassis. Whereas when you're looking at this production chassis, this is quite a meaty setup that you're seeing here. Question is, why? So let's think about it. If we were able to put this chassis with a press at one end and a press at the other and we squeezed it together, the likelihood it's going to bend on these spars in the centre. So essentially they are the weakest part. Now what then gives them the strength? And the answer is the engine. We've all heard the term, or hopefully we have, a stressed member. That's not a mate who's under a bit of pressure. It's literally the engine sat in here. And going from the weakest point on a chassis, it now becomes the strongest point on the chassis. Now let's imagine on our ST765 we're going to go touring across Europe. We've eaten one or two many pies. We're probably 15 stone with all of our gear on, maybe a little bit more. We've got our partner who's of a similar weight, and then we've got 20 kilos of luggage that we're going to haul with us. Now the interesting thing about that is that's a lot of weight on the motorcycle. So when the manufacturer designs it, what they're going to do is they're going to strengthen key areas. Imagine going down a road, not noticing a hump, what we call in the UK a sleeping policeman, designed to slow traffic down. Imagine you don't see it and you hit that with a reasonable amount of force with 2 heavy riders and 20 kilos of luggage. What is, without an engine, the strongest part on the chassis, this front part here, now becomes the weakest part of the chassis. And if you look at it, all the rear end of the chassis here is bolted up to the back of the engine. The spars are also bolted to the engine. But once we get here to the front, this section here, that lot is hanging out in the air. And that essentially is the weakest part of the chassis. And that is why they build so much strength into it. Because they understand that you're going to be carrying unknown weight on the bike, unknown road conditions, and whether it be sleeping policemen or it happens to be a big unexpected pothole, something that we're very used to in the UK despite paying vast amounts of road tax, it could essentially crack one of these spars on the front. So these are quite heavily beefed up. Now you might say to yourself, well, why is that a problem? Why is strength a problem? Let's just imagine for a moment on our front forks here and then down to our front wheel, we've got a tiny contact patch going on the front wheel, which is the only thing holding us to Mother Earth. When the motorcycle is fully leant over, and I'm now talking about a track and to a degree the road, but I'd rather you didn't ride like that on the road, that's track work. When the bike's fully leant over on its side, the suspension is virtually fully compressed. It should be if it's working correctly. Even on a race bike, we look to use all of the travel that's available to us. It's there, why not use it? When it gets down the bottom, there's very little movement in it. Now, imagine mid-corner, you hit a little bit of a bump or some ripples or something, and the bike starts to twist a little bit. It starts to object. Now, what's happening there is you think the chassis is flexing, and probably to a small degree, a nominal degree, it is. But what's really happening is all of that weaving force is being transferred down to your front and rear tyre. And if you look at the tyre in the corner, if you could film it really slowly, and I'm sure we've all seen it on the racing when they do slow-mos, the tyre is completely deformed at that point. It's really squashed up on one side. And so essentially the tyre is moving across the tarmac like this and acting as a third party, second party actually, suspension. Your first party is your physical suspension, but once that's down and fully compressed, imagine in a corner you've got the G-forces, you've got the weight of the bike and the weight of the rider as well. So it will be fully down. Your suspension's not doing much at that point. Your chassis can't do an awful lot because it's quite stiff, and therefore the only thing left to do all the work for you are the tyres. And that's when we start to see handling problems, if you like, tyre wear issues. Not in all instances, but you easily can do. When you look at that prototype chassis down there, you can't see it, and I can't come round to the front because if I do, the video is going to cut my head off. However, on the very front end of that chassis, we've got a couple of plates with holes in it with which we can run a bar, a torsional bar across the headstock. Now that torsional bar, let's just say for instance, it's round at the ends obviously, but in the middle it's a flat piece of bar. Now take a steel rule or a plastic rule, plastic's even better actually. If you have it flat in your hands, it'll bend quite easily. If you turn it so it's sitting vertical, the width is vertical, now you try and bend it, you can't do it. So the torsional bars that we put on the front of the prototype chassis are effectively doing the same thing as this. We're able to beef up the front end if we find we're getting too much flex out of the front of the bike. And the big question is, well, why do you want flex anyway? Well, as I previously explained, if all you've got left when the suspension is bottomed out is your tyre doing the work, we want the chassis to move with it. We want the chassis to give a little bit so that it can move very marginally with the tyre and take some of that pressure that the tyre's experiencing off. Now, reality is you can't do that with a production chassis. So one of the first things that we start talking about, and what you can see on this motorcycle here, are a completely different set of yokes. I only put these two bolt holes, which you can see on the outside of the bottom yoke. All of the material underneath is cut out with various strengthening struts applied in certain areas. But those yokes are designed to flex. The tubes in your suspension are designed to flex. So the idea is what we're losing out because we've got an extremely stiff chassis at the front is something we can hopefully recoup to a degree using the adjustable yokes, top and bottom, and the suspension tubes themselves. I hope you can see the visual comparison between the prototype chassis and the stock chassis, and hopefully you're now beginning to understand when you're watching Moto2 bikes race. Well, that's not strictly true. When you look at a Calyx, it can be quite chunky at the front end there, but it's a very thin material and it does allow flex. This chassis that you're looking at down here was a chassis that I first, or not me personally, a professional rider, first demonstrated at BSB back in 2017. The story is quite simple. When I finished running the Triumph Triple Challenge at BSB, I wanted to do something to continue the development of young riders. I tried to talk the powers to be into putting a Moto2 championship together at British Superbikes, and in reality we did get there, and it was called GP2. But that chassis you're seeing down there was the first one that ever made a debut at BSB. I should imagine it was the first ever prototype bike that made a debut at BSB, certainly in the middleweight class. Such was its performance that on the very first time we went out, which was at Donington Park in 2017, the bike went to pole position first time out. And my favourite round was Brands Hatch GP in August. It had rained, the circuit was wet, and such were the grip levels that we were able to get out of the motorcycle because of the structure of the prototype chassis and also because of the swing arm. We finished a full 29.97 seconds in front of the rest of the British Supersport grid. Such is the difference between a production chassis and a prototype.